Hello, it's Mr. Harrison, if you couldn't tell. This lesson is for my calculus students, my pre-calculus students. We're going to be doing lesson 38. I'm on page 196 and 197 of your book. We're only going to be doing the first two examples first. Going to make a second video for the later ones, a little more complicated, and I don't want to get stuck up into this one. Here's your very first example written up. Well, before we do that, let's read it. It says, the slope of the tangent to a curve at a designated value of x can be found by evaluating the derivative at the value of x. We've talked about this before in different language, that if you want to find the slope of any graph, any function, if you will take the tangent line at any specific point where it touches, the slope of that tangent line will be the slope of the entire graph at that point. More on that later. Let's get right into this very first example. It says, if y equals x squared minus 4x plus 3, compute dy over dx slash 3. It says right here, find this. Well, dy over dx, you know, is the symbol for a derivative. So we're going to find the derivative. And this line with a 3 on it just simply means we're going to find what the derivative equals when x equals 3. Okay? Now before we get into this, I want to talk about this equation. Just looking at it, you can tell me that it's a function, it's a parabola. Over there to the far right, I've showed how we can solve this parabola to find information to go graph it. First of all, the x squared minus 4x plus 3 we know is a factorable expression. I can factor it out, x minus 3, x minus 1. If I set those both equal to 0, we will get that x equals 3 and x equals 1. On a graph, I'm going to change this up a bit. I'm going to make this a little bigger. We know that our parabola will cross at those two places. At 0 equals 1, x equals 1, and x equals 3. Over to the far right, I've completed the square with this. You remember that when we complete the square, it gives us new information. As I've always told you, anytime you rearrange an equation and solve for different things, it gives you new information. When we factored it, it gave us our zeros, where it crosses the x-axis. When I complete the square, I get this equation, y equals x minus 2 quantity squared minus 1. That gives me x equals 2 is my axis of symmetry. You remember that. Let's see if we can do like that. I can't do it like that Harvard professor. There we go. There's my axis of symmetry. It also tells me my vertex is at -1 on the y-axis. Right there is my parabola. Okay, now we're going to use that to go answer this question we have over here. They want to know not the equation of the line, but the slope of this parabola when x equals 3. Well, right there, they want to know our slope right there at that point. That's what they're asking. And what did I say when we first started learning about derivatives? Derivative is just a fancy name for the slope. So what is the slope of this? Somebody may go, oh, the slope is 2, it's 1. No, if we will take the derivative of this, then we'll be able to find the slope. So we take the derivative of x squared. So this is dy over dx. That's definition of slope. Gives me 2x, because the 2 jumps to the front, and minus 4x to the 0. And what is the derivative of 3? Well, that's 3x to the 0. So that's just 0. X to the 0 is 1. My derivative is 2x minus 4. That's the slope of that line. Well, that doesn't look like a slope for me. Well, The question is, what is the slope, as I said, when it said dy over dx and had this 3, that means when x equals 3. I'm going to go plug that 3 in right here. It says that my slope right here is 2, meaning it's going up 2 over 1, up 2 over 1, up 2 over 1. The way I've drawn it, it looks like a slope of 1. We're not going to worry about that. If you will look at the picture on page 197, though, they do have a picture of this with the slope. Okay? So, there it is. One thing I need to point out, common mistake people will make is they'll say, oh, all I have to do is take this 3 and plug it in up here. 3 squared, that's 9. 4 times 3, that's 12. 9 minus 12, that's negative 3. Plus 3, you get 0. It doesn't help. Don't plug the 3 in to begin with. Take the derivative, then plug in 3. And that will give you the answer to this equation. Now, the second question says, find the equation of the line tangent to the graph that we just did. In other words, right in the first question, all they asked us to do was find the slope. The slope was 2. Now they're turning around and saying, okay, what's the equation of that line? 2 things I always tell you need to find the equation of a line. What are they? Point and a slope. That's actually 3 things, because a point is made up of an x and a y, and then we need the slope. Okay, so what's the equation of this line? Well, do I have a point? Yes, I do. That point is 3, 0, my x and my y. So we're at 3, 0. And I know my slope. My slope is 2. We're going to put it into that equation that I always tell you, the point-slope method. Y minus the y they give us equals slope. X minus the x they give us. So, in this case, y minus 0 equals 2. X minus, and what is x? It's 3. Work that out, we get y equals 2x minus 6. The equation of this line up there is 2x minus 6. It has a slope of 2. If we will run this all the way down, it would pass through my y-axis at negative 6. That's all there is for this lesson. We'll be covering examples 3, 4, and is there a 5th one there? Well, later on, higher order derivatives. It's pretty easy, not that bad a problem. We'll get those on the next lesson, on the next video. God bless. See you guys soon.